All right, let's talk about it. Why does your AI agent have the memory of a goldfish? And, more importantly, how a 50-year-old idea is pretty much the only real way to fix it. Oh, you know the feeling. We've all been there. Message 1, your agent is a rock star. It gets your project, it knows your goals, the whole shebang. Then you get to message 11 and it's, who are you again? Ugh, you feel that pain, right? We've all spent nights debugging that exact loop. And here's the thing everyone gets wrong. They blame the model. Oh, GPT-4 is just forgetful. No, it's not a model problem. It's not a bug in Claude 3. It's an architecture problem. The way we're all taught to build these things is fundamentally broken. The blueprint is garbage, so of course the house is going to fall down. Okay, let's get one thing straight, because this is the core misunderstanding. The context window is not long-term memory. Think of it as RAM. That's all it is. It's super fast, stupidly expensive, and the second that session ends, poof, it's gone, completely wiped. Building your agent to rely just on the context window, it's like trying to build a brain with only short-term memory. It's never going to work. And look, I know what you've tried. We've all tried these so-called fixes, right? Just stuff more into the context window. Yeah, have fun with that token bill. Let's just add a vector database. Cool, now your agent's memory is a fragmented mess with no audit trail whatsoever. Oh, I'll use a special memory module. It's just a hack, a clunky add-on that never quite works right. They're all just band-aids on a gaping wound. So what's the real fix? It's not some cutting-edge 2025 breakthrough. Nope. The answer? It comes from 1974. I'm not kidding. Over 50 years ago, computer science basically solved this exact problem of how to handle a bunch of different kinds of information in a system that actually makes sense. And here it is. This is the whole idea, from Ken Thompson himself. In Unix, everything is a file. That one principle changed everything. Your keyboard input, that's a file. A network socket, also a file. Some random hardware device? Yep, you guessed it, it's a file. Everything speaks the same simple, elegant language. And you can see how this maps directly to AI agents. It's a perfect one-to-one fit. The user's feedback? That's just a file. The JSON output from some tool it called? It's a file. The memory of a conversation from last Tuesday? It's a file. The core knowledge it needs to hold on to? You see where this is going. It's all just files. And the moment everything is a file, you get a path, you get metadata, you get version history, you finally have a system you can actually govern and audit instead of some chaotic black box you just pray works. So this whole idea has been formalized. There's an archive paper on it, and they call it the Agentic File System, or AFS. And this is key. It's not just a cute analogy. It's a full-on architectural pattern for building agents that don't have amnesia. All right, so let's pop the hood and look at the blueprint. The AFS is built on 3 simple, coherent layers. Okay, let this sink in. At the very bottom, you've got the history layer. This is your agent's black box, its flight recorder. It is append only. Nothing ever gets deleted. Every single action, every tool call, every bit of user feedback, it's logged forever. This is your immutable audit trail. Then, sitting on top of that, is the memory layer. This is the structured, indexed knowledge base that actually survives a restart. And finally, on the very top, is the scratch pad. This is the real equivalent of RAM. It's a temporary, volatile space for the agent to think, to work things out, without trashing its permanent memory. And what's so brilliant about this is that it's not just borrowing from computer science, it's also borrowing from cognitive science, right? These 3 layers map almost perfectly to how our own brains work. You've got your episodic memory for recent events, your semantic memory for core facts, and your working memory for what you're focused on right now. It's an architecture that's been battle-tested by, evolution. Okay, so that's how the memory is stored. But how does the agent actually use it during a conversation, turn by turn? Well, that's where the 3-stage context pipeline comes in. So, in every single loop, this happens. First, the constructor scans the memory and intelligently picks out only the files that are relevant to the current task. It compresses them to make sure they fit inside that precious token window. Next, the loader takes those selected files and mounts them into the prompt. And critically, it includes all the metadata, the file path, the timestamp, everything. This way, the model knows where its information came from. And last, after the model gives its response, the evaluator takes any new insights and writes them back to the file system. It's a perfect closed loop. Nothing gets lost. You can really think of the constructor as a bouncer for your context window. It knows the club has a strict capacity, the token limit. So it grabs the VIPs, the project goals, the key facts, the most recent chat history, and it lets them in. And if something doesn't fit, it doesn't just crash. It gets left outside, and that decision is logged. It's a conscious choice, not just a silent, mysterious failure. And just in case you're thinking, okay, this is a cool idea for a research paper, wrong. This is not theoretical. The open source framework OpenClaw is already built on this exact principle. It's running in production right now. You can go look inside its workspace directory and you'll literally see the agent's entire state laid out as plain old markdown files. It's real, and it works. So let's talk about the real cost here. The old, naive way means you are constantly burning tokens, re-explaining the same context over and over again. The agent's state is totally volatile, and let's be honest, your trust in it is basically zero. With AFS, yeah, there's a small cost to load that initial memory, but after that, it's persistent. And here's the magic word. It's inspectable. When your agent does something weird, you can literally just open a terminal, cat a file, and see exactly what it was thinking. That right there, that's how you build a system you can actually trust. So I'll just leave you with this one thought. If your agent's memory isn't actually written to disk, if it's just a temporary electrical charge in a context window that's about to get wiped, does it even really exist? The context window is RAM. The file system is your hard drive. It's about time our agent architectures figured that out.